And we are recording.
Okay guys, we'll start now. And we had a lot of requests saying that some of them have workshops. So you can inform your friends that the session will be recording and the recording will be shared by the end of the day. So they can view the recording in case they're not here because of the workshops. So that's a short announcement, and now we can start. So this is Team Abhiyaan and I'm Shashank, a fourth year student, IIT student pursuing chemical engineering and majoring in data science. And I've been part of this team for 4 years now. And yeah, that's just a bit about me. We can start with the orientation now. Okay, you see a number on the screen. What thoughts come to your mind? Interesting answers will get goodies. Sachin Tendulkar, Virat Kohli, huh? Who's F1? Okay. Emoji. Okay, interesting answer. She can get one goodie. What else? Any other answers? S grade. Number of 100 males. Lost and found males. True. How many of you can read that? None. Internet speed. Yes. Anything related to Abhiyaan which comes to your mind? Why do you think you would have put 100 over here? Okay, let me reveal. So basically, that's the number of people who would have died due to road accidents in India alone by the end of this orientation session. And 94% of them, basically 94 of these road accidents would have been due to human error. And this can clearly be avoided, and that's how our team was born. So this is not working, you can continue. Yes, so we are a team of 25 students committed to building intelligent, precise, safe ground navigation systems, and our team is basically divided into 4 modules: software, electrical, mechanical, and business module. We'll go over each of these modules later. We'll tell them what exactly each module does. Now I'll just, since we are a competition team, I'll talk about the competition we participate in every year. So IGVC, which stands for Intelligent Ground Vehicle Competition, it's an international competition which is held at Oakland University, MI, US every year, and it's a competition which is sponsored by US Army, and it's held in the first week of June every year. And yeah, there are 2 stages in this competition. One is the Autonav stage 1 and self-drive challenge, which is the stage 2. So as you can see from the glimpse of Autonav challenge, it's basically a prototype which we built, and it has to pass through an obstacle avoidance course. And self-drive challenge is more like an urban environment where something like parallel parking, intersection detection, barrel detection. So basically simulating an urban environment. And next slide. So I'll just walk you through a brief journey of our team. So our team was founded in 2016, and our first participation in IGVC was in 2017, where we were placed 13th overall. In 2018, we were placed 10th overall. In 2019, we were placed 2nd overall globally amongst 45 adult teams, winning the Grand Let's trophy. So enough of pictures, I'll show you a video of our champion bot Virat, which was demonstrated at the competition. So you can turn on the sorry. Yes, that's a short video. Yeah. So in the early part of 2020, we took part in KPIT Sparkle. It's more like a business plan competition, which was completely held, taken care of by the business module of our team. And we were one of the 30 finalists among the 3,000 teams which had participated. And it was under the theme Mobility for the Future. And and then COVID struck and everything was converted to online. And one such opportunity we seized was Indie Autonomous Challenge. It is the world's first high-speed autonomous racing competition, and we were one of the only 6 Asian teams to qualify for the first round, and we successfully completed the first 3 rounds of this competition, and all these first 3 rounds were completely online, and we had to do it in simulations. And our software module especially had a steep learning curve during this competition, and we had the chance to interact with teams across the world like MIT, Travelers, Georgia Tech, etc. And it was a great learning experience for the team. And due to monetary and travel constraints, we were not able to go to the next stage of the competition, but we take back with us the experience we had in this challenge. Next. Now coming to what actually we are doing now, what the team is doing now. So you would have seen the prototype Virat which we had for IGVC stage 1. Now we have taken a step up and we are actually using a real driverless. We are actually building an actual self-driving vehicle, and it was recently demonstrated at the C5 open house, which I guess some of you, we had circulated this video recently. And so we have been working on this self-driving vehicle since November 2021, where we had the opportunity to come back to the campus. And yeah, now I'll show you a short video of the work we have done on this self-driving vehicle. So this is the C5 open house demo which happened in the March 2nd week. And that's the director in the vehicle. Okay, that's me. Beside me is the director. So this is the 100-meter obstacle avoidance course which we had with this real self-driving vehicle. And yeah, this is the autonomous navigation. We had barrels as obstacles over the course. Okay, yeah, this was the run, C5 open house run which we had, the first 100-meter autonomous navigation of our vehicle which we demonstrated. And now coming to another project which we have taken up. Before that, you can see there is macro written on the slide. Anyone here knows what macro stands for? Correct answers get goodies. You can give them mic. You can raise your hands, whoever knows the answer. Women
raise your hands, we'll give you the mic.
It is Martian Autonomous Core Sampling Rover.
Yes, that's the right answer. So basically this is next slide. So this is a research project which we have taken up in collaboration with XTEM, which stands for Extraterrestrial Manufacturing. It's a research group at IIT Madras, which consists of professors in IIT and across the world, and we also have industry collaborators for this research group. It is so the project Macro, which we have taken up, it's a funded project, and this research group is headed by the director of the institute, and Professor Satyan Subaya is Professor Satyan Subaya in mechanical engineering department. So you can see that they have collaborated with our team to work on this project. So this project, just to give you more about this research project which we have taken. So we are actually building an autonomous drilling rover which is capable of drilling up to 1 feet and collecting samples from the Martian surface. That's what the project is in 2 lines. Now, next slide. Now coming to the timeline we have for undertaking these 2 projects. First, I'll talk about the Institute shuttle, which you would have seen the vehicle where we showed a C5 open house demo where you saw the vehicle. So that is for the first timeline, Institute shuttle. The second timeline is for Macro. So I'll just walk you through the first timeline which we have. Basically, you people who will be recruiting will be engaging in these 2 projects. So the first, the green ones are the ones which we have already completed. We have procured the vehicle and completed the drive-by-wire system, and we have completed software integration for it, and we had the C5 open house demo recently. And our next task is to demonstrate this vehicle at IGBC, which is the competition I talked about, in June first week this year, that is June 2022. And since we are planning to have a shuttle, we are planning to procure a 6-seater. The current vehicle which we have is a 2-seater vehicle. Shuttle would make sense if you have a 6-seater vehicle, so we are planning to procure it by August 2022. And there will be a full-scale demo from either main gate to GC or GC to Mandakini in December 2022. The demo we showed was just 100 meter. We want to show a full-scale demo of autonomous navigation. And then hopefully in 2023 we want to have a collaboration with other industries where our solution can be deployed further. And now coming to Macro. Macro is a project which we took up recently last year, and we have completed the design of the rover, and then we are planning to start the manufacturing by July 2022. And the test bed demo is basically since the Martian surface is not similar to the surface we have on Earth, we have to first create a Martian surface, so we have to have a test bed which is similar to that. So we were planning to do that by December 2022. And the first prototype will basically be a rover with the driller which can drill through the test bed which we have created up to 1 feet and collect the sample. And then the software integration is basically to do the drilling autonomously. The previous prototype it will be RC controlled, the next one it will be doing autonomously. And the simulated test environment is basically to simulate the whole Martian environment, including the temperature and the weather conditions which are prevalent there. So that is, we are planning to do it by March 2023. And the second prototype will basically be an autonomous, what we had planned, an autonomous drilling rover for Martian surface. And hopefully by August 2023 we can collaborate with ISRO to deploy this on Martian surface. over to Sudarshan to talk about the design of macro and further.
Hi, I'm Sudarshan and I'm looking over the mechanical module in Team Abhiyaan. So as you can see, this is the rover that we have designed. So this is basically a rocker bogie mechanism that is developed by NASA. It has the capability to climb over obstacles that is twice the height of the wheel diameter. And the rockers are connected to each other through a bar differential that you can see. Basically what it does is it tries to maintain the contact between all 6 wheels to the ground. So this is one of the CAD model that we have made. So as you can see here, there is one thing that's missing here. Can anybody guess what's that? Yeah, this. So more specifically, please. Like, what do you think is something that's missing here? I am. Okay, somebody said something.
Robotic arm.
Yes, it's the robotic arm. So that's called the manipulator arm. So this is the manipulator arm that we'll be planning to use. So can someone guess the weight of the manipulator arm? So to make things easier, I'll also give you the exploded view of the manipulator arm here. You can see it's way more complex than you guys think. It's not just 4 bars that's connected to each other. So wait, we'll have a countdown. I want everyone, most of you guys should say any random number, that's fine. 69, I heard 69. 250, 15, 2.5, 1.5, 100, 3, 5 grams. Somebody else, I get more response from this side. 6, I hear somebody saying 250 grams. From the last, 420, 8 kg. Sorry? 4 kg. 5. Okay. Some more. You have still 10 seconds left. 10.7. I see a nice decimal number there. 750 grams. Okay. 42 grams. Okay. Your time's done. So, what do you compare with? Say, I see most of you saying in tens. But what it actually does is it weighs as much as a cruiser bike does. It's massive. It's 257 kg. Oh, that's pretty big to handle. Right? So now you can see the scale at which we intend to build macro such that it will be able to stabilize the vibrational load from the manipulator arm. So, you want to know some more technical details about macro? You guys are interested? Because something very interesting that we have not touched before. Something that we are starting from scratch. So we are equally excited to tell you more technical details. Do you want to hear? I don't want to make it so technical also such that you guys will be bored.
Yes.
You want to?
Yes.
That's a secret. See, we are in the process of filing a provisional patent. So at this point in time, we will not be able to reveal the technical details. So if you are curious enough, do join the team. You might be able to be one among us to file a patent, and that will be under your name. So now I hand it over to Christy, who will walk you through the mechanical module.
Hi, I'm Krishti. I'm a third-year student from aerospace, and I'm doing a dual degree in GS as well. Okay, so I'll show you a small glimpse into how the mech module actually works. So we not only design, we manufacture as well as assemble various components for the vehicle for our team. So in this video you can see one of our late night assembling of the brake-by-wire for the bolt that you guys must have seen in Himalaya or near Vindhya as well yesterday. Okay, so I'll give a brief overview as to how things work in the mechanical module. So first we start by conceptualizing whatever we are supposed to design, after which we do a on-paper design. After that we make a CAD model, and then finally move on to manufacturing and assembling the whole object. Okay, so let me take you through the entire process by giving you like examples of what we did for Bolt. Okay, so yeah, like this is basically a very long journey from putting in your hard work to finally being able to sit in the autonomous bowl that you've only built from scratch, of the various systems that you've built from scratch. You can see that from pushing it to actually making it work autonomously, it's a very fulfilling journey that you'll get to experience if you join the team. Okay, so talking about the conceptualization, it's a very intriguing process because we have intense discussions and a lot of ideation takes place into actually coming out with a plan for how you're going to proceed, because there are a lot of constraints that are there, be it space constraints or even like constraints from other modules like the software or electrical module. There are a lot of things that needs to be considered before you can actually move on to designing something. So first, this is a very long process and sometimes boring, but then it's very important and integral part of what we do. After that, we move on to on-paper design so that everybody is on the same page and everybody knows what we are, working towards. And during this whole time, basically your idea is taking shape and it's being molded into what you want it to be. Next, we start designing the actual model. We use different softwares like SolidWorks or Fusion 360. And these are few of the models that we have built, and you must have seen most of them like actually there in the golf cart that we have. After that, after we finish making the model, we have to do a stress analysis. So we do a finite element analysis so that we know that it's above all the safety precautions that needs to be fulfilled. So this is the most fun part of mech because not only do you get hands-on experience on stuff that like really matters and stuff that actual engineers do, but you also get to look really cool while doing it. And you get to like use power tools, as well as you must have seen the workshop, and most of you must be already going there. But this is like only a one-time thing that happens. But if you're a part of the team, you'll get to go and use it on your own and use the lathe machine, the milling machine, and actually be able to contribute in a big way. You'll also get to go to different stores and buy the necessary materials, which will give you a proper real-life experience and make you get skills which is very relevant in the real world, because this is like industry level experience that you'll get if you join the team. Yeah, so after you finish manufacturing, we assemble everything together. So here you can see an actual working model of an assembled brake-by-wire where the linear actuator is being pressed and the brake is being applied. So this is like a working model of the brake-by-wire. And this is the working model of a steer-by-wire where we have used gears and a stepper motor to turn the wheels. Yeah, so what you'll learn if you join the mech module is, along with all this is like stuff that you can kind of pick up on your own as well. But more than this, you'll work in a very welcoming environment, and you learn how to think outside the box and how to be creative, which is very vital and essential in the real world. Yeah, so it's truly heartwarming seeing an idea of yours which is just in your mind to actually be converted into something and being used in a very real world application. So it's truly heartwarming, and you'll get to experience your own idea being converted into something in real life, and it'll just be out of the world. So yeah, I'll pass it on to Adil.
Hi guys, I'm Adil. So, any Vijay fans here? Any cheers? So, let me introduce you to the beast of Abhiyaan, that is electronics module. So, let me hand it over to CJ Adityan for more.
Yeah, so hey guys, I'm Adityan CC from electronics module. So as we've seen, moving on from the neck module, we'll be talking about the electronics module. Sorry guys, I'm nervous. Long time later. Okay. Yeah, so electronics module is basically the powerhouse of the team. What we'll be doing is we'll be integrating the hardware and software parts of the vehicle. And moving on to the next slide. So now we'll see like what we have done till now and what are the subsystems of the electronics module. And next we'll be seeing what are our plans for the future goals for the vehicle, and from a functioning prototype how we'll be going to a autonomous shuttle service inside our industry using the vehicle. And third, we'll be seeing what you guys will be working on when you join our team. So, okay, basically we have 4 subsystems in our electronics module. So one is driver system, which my module already talked about. The second is embedded systems. So you know IoT, right? So Arduinos and ESP32s. You'll be using microcontrollers to give commands to all the IoT devices present in the vehicle. And the third is the communication system. So how will you communicate the commands across the various parts of the vehicle from the computation module. And fourth is power distribution system. So this is an important one because if it cuts, then the whole vehicle might explode as well. So that's the fourth system. So and now the actual best is tech beast Adil Mohan. So I'll be handing over to him.
So, hi guys again. So basically, what embedded system is the brain of all the electrical systems. So basically, in layman terms, it accepts the required velocity and the angular orientation of the vehicle, which is provided by our software module. And then it converts that into the required throttle, steering, as well as brake commands, which is then implemented by our driver systems. Basically, it acts as the brain as well as the hands and legs, similar to a human being. So, coming to our microcontrollers, we have over some 8 hobby microcontrollers like Raspberry Pis, Arduinos, ESP32s, which is, to be honest, 8 is a bit overkill. Cost-wise as well as getting into debug, solving it, as well as from a safety point of view. So in the next few years, next few months, we are dreaming big. So that's why we are going to make an autonomous Insti shuttle. The Insti shuttle. So for that, we will be replacing all our embedded systems, all our drive-away systems to industry standard, to automotive industry standards based on ASIL, or automotive standard for integrity levels, which is based on ISO, which is basically a safety certification. So for that, we'll be replacing all our microcontrollers as well as the processors, which are custom made or tailor made for automotive industries. And we'll also be making a new PCB, which will be more robust as well as reliable. Coming to communication systems, I would like to hand it over to AMS.
So hi guys, I'm AMS Arun Krishna from electrical department. I'm co-heading electronics module with Adil Mohammed, who just spoke before. So talking about communication systems, the thing is that the autonomous self-driving car is a very complex engineering project. You cannot run a single Python file or C++ file and run the entire functionality in a single file itself. So what generally happens is that you have multiple programs that are running parallelly at the same time. But the issue is that all these programs have to communicate with each other. Say transfer some information from one point to the other. So this is where ROS comes. ROS, the robot operating system, is a software framework that we use, which is actually used to transfer messages from one program in a system on a network to another program in a system on another, in a computer on another network. With respect to hardware protocols, so we are using well-known USB serial communication right now to transfer information from one microcontroller to another microcontroller. But the thing is that this is not exactly industry standard. So to move to industry standards, we'll be replacing it with some automotive specific network. Do you guys know what it is? Anyone? Any more?
Then just raise your hand and I'll just pass you the mic.
Correct answer. So a core CAN and a bus, a CAN bus. It's a controller area network that we'll be actually implementing going forward. So this is kind of ambitious from our aspect, from our area as well. So what we are planning to do is that we are planning to implement 5G communication system in our vehicle with the help of 5G testbed IIT Madras. This is actually headed by the director of IIT Madras, Kamakoti sir. So this is actually very much required because as we move towards autonomous shuttle on an industry level, we need to actually do something like vehicle to vehicle communications and vehicle to infrastructure communication systems. So a 5G communication system will provide necessary data rates for us to actually achieve that. It's a very interesting, very challenging, at the same time it will be, you will have a very steep learning curve when you guys actually work on this. And we really hope we'll be able to do this in the next following year. Finally, to the last electrical subsystem of our vehicle. So we have primarily two batteries, a primary lithium-ion battery that actually drives the vehicle. So basically it provides the traction for the motors, etc., etc. Whereas a secondary lead-acid battery that actually provides the drive-by-wire system and the computation unit of the vehicle. The thing is that lead-acid battery has a lower energy to weight ratio compared to lithium-ion batteries. So in the following year, we are trying to actually replace this lead-acid battery with the lithium-ion battery that is made in-house by ourselves. Okay, so guys, I'm showing you guys a video. Maybe it could be a bit violent for some people, I don't know. Exactly. So recently, if you guys have actually followed news coverage for a while, there have been a number of electric fires happening in EV scooters in India. Do you guys know what is the reason behind this? Any guesses?
You're gonna just put it up.
Anyone else? Come on, people, answer.
Lithium-ion.
Correct. He's also correct. Anyone?
Anybody else?
In the back, can you hear us properly?
Yeah, guys, please sleep. Don't sleep off.
You can't hear us, you can't see us, then the stealth.
Sorry?
Overheat.
That's correct. So, what do you guys think that we can do to actually prevent this from happening? Okay. Any more? Any more options?
Who said chocolate?
Alternate material for batteries.
Okay. Any more?
Inside the vehicle.
Cool. Any more?
Anybody else?
Sorry? Cool. Any more? I'm getting interesting answers right now.
Yeah.
Using water cooling systems like using paving pieces.
Okay. Any more?
Anybody
Is
else?
there
Just
anyone?
raise your hand. I will just pass you the mic.
Last bench guys usually have very drastic ideas. We really need to hear some.
Using materials which are better thermal operating windows.
Okay.
I
Okay.
want somebody from the back to answer the last row. Somebody.
Last one.
Yeah, you guys have an extra.
We can't see any of you, so.
We can't see any also, so at least you watch us. Somebody, yes, it's one person's duty. Anybody to answer? Just raise your hand.
Okay, so actually most of your answers are really good and most of your answers are correct. Okay, we'll actually go through each one of your answers as well. So someone said air vents. Technically, every lithium-ion battery is actually required to have air vents. This is because, say, if something goes wrong, the entire container will be filled with gas and that could explode. So people actually, as in the manufacturers, have air vents in the system. And people said about cooling systems, so that is also true. But the thing is that normally EV vehicles generally don't have any liquid cooling systems. This is because of the fact that there will be huge weight and volume associated with it, not to mention cost. So cooling systems also a correct answer. And someone said about software, so a battery monitoring system. See, the thing is that it's actually very important. We'll come to that next. And is there someone said about biofuels? So the thing is that it's also a really good answer. It's also a really good answer, but the fact is that we are trying to go towards EV, so without having any kind of combustion fuels over there. So although the answer is correct, we are not going towards that. So the main thing is that all of these problems could actually solve by actually using something called as battery management system. Battery management system basically measures the parameters of the battery. Say something like cell voltage, cell current, cell temperature, and some things like that. So by actually monitoring all of these parameters, what exactly happens is that, say suppose if something is going to burst up, obviously it's going to overheat. So by actually monitoring the temperature, we can predict stuff going back beforehand and try to solve it. So the thing is that we haven't implemented battery monitoring system till now in our vehicle. So in this next following year, we will be definitely implementing a battery management system along with a lithium-ion battery that we'll make in our by ourselves in-house. So yeah. Finally, let's talk. Okay, so this is the weight of our entire drive-by-wire system. So you guys, as you guys can see, it weighs around 85 kgs, including the inverters, the secondary batteries, the steering actuators, the linear actuators for the brakes. It weighs around 85 kg. That's about 25% of the vehicle. The thing is that 25% of the vehicle is a very big amount. It's very heavy. So what our plan is to actually reduce everything by 35%. Reduce the weight, cost, volume by 35% while actually increasing the power efficiency and increasing the safety standards of the vehicle. So on overall, we want to do all of these for all our electrical subsystems in our vehicle. So what exactly you guys will be working on? To be honest, instead of me telling it, let's actually see a video of what kind of stuff that you guys will be working on. thought we could share some bloopers that we did. Some break off at any time for some no reason. So yeah, they're actually the fun module of team. The other guys are very serious.
That's basically Mac module bro.
Okay, so moving on, we are going to talk about software module.
Okay, hi guys. I think you guys saw that video of how things actually go on. Things are starting randomly, stopping randomly. Now we're coming to software module. So I'm Suraj. I've been in Abhiyaan for 2 years. Actually, essentially what we have to do with software module is we get a lot of data from the environment, all noisy, extremely horrible data from pretty bad sensors. And we have to make the right decisions at every time. Every time we have to take all this data, process it, filter it, clean it, run our algorithms and actually give the right decision for the vehicle. All of these things need to happen in real time constantly, right? Because if even for 1 second you fail, something can happen to the vehicle, it will crash, it will go off and you can't afford that. So software module has like some 4 or 5, we'll say sub-modules, different domains that we work in. So suppose the vehicle is moving and suddenly a pedestrian comes in front. First thing that will happen is we have our sensor suite, the cameras, a couple of sensors are there, we'll get to that. So they will detect that a pedestrian has come, right? So that's the perception module. That data we'll take, we'll apply some processing to figure out exactly the speed of the pedestrian, where it is in the world, done by the processing sub-module. Then we work with path planning. So what path planning means is, given a specific goal location and given the environment, all what pedestrians are there, where the lanes are, etc., to find the best path from your current location to the goal position. And in the end, we have to run our controller. So what a controller does is it will take that path and try to follow it the best it can. It's the glue between software and elect module, right? So all of this has to run real time over hardware. It cannot fail. It can never fail. If it fails, then we have serious problems. And all of this we have to access via user interface. So usually we don't really think about that, but that's something that we need to work on. It's important because especially in self-driving vehicles, we face the user directly. Somebody will be sitting inside. That fellow will see. He needs to have good interface and experience, right? So yeah, these are some of the sensors. So how many of you actually saw the vehicle before? Raise them high. Okay, not a lot. These you guys saw in the PPT, I think. Before you should have seen some videos. So what sort of sensors are generally used for autonomous driving? Does anybody have an idea? Somebody raise their hand. I can't, see everybody. Red T-shirt, CRVD, right? What's your name? Name? I'm Jayan. Okay, he's Jayan, CRVD, everybody, look at him. So what sensors, stand up bro. So what sensor we talking?
So there will be camera, there will be ultrasonics, there will be the GPS modules, there will be...
Can you point out GPS on this slide? Can you guess? No guess? Okay. Yeah. So camera, GPS.
There will be microphone, there will be temperature, humidity, and things like that.
Okay. The microphone, temperature, humidity, not actually used. Could definitely, maybe sometime. Microphone sounds like something which could be useful. But so see, here we have, first thing over there is a LiDAR. Okay. The first thing on the left is the LiDAR. So this is the sensor which essentially shoots laser beams. It shoots laser beams and it hits the environment, gets reflected. Right. So if you go to the next slide, we can see some sample output that we get. So a LiDAR is extremely long range sensor, it's extremely costly, but it's extremely accurate. So it can give you a map of the environment and tell you where you are. Right, next slide. Next most important sensor we have is the camera. That's the one in the bottom left. That's something called the stereo camera. It's basically a 3D camera. It gives you full 3D output of what it sees. Slide. Some of the exact sample output that we can get from those sensors. It can build a complete map of the environment with colors, 3D map. And finally is what could be the most important part. So when we are walking, we have some sense in our head of where we are with respect to the world. But if you have like a robot or a vehicle, it's not that easy. It's not something that automatically happens. We use a combination of GPS sensors, IMUs, and encoders to track our position in the world. Slide. Okay, this is some example. You guys know what building that is? Have you seen it before? It's on campus. Yeah, NAC. It's a Google Maps view of NAC. So this is one of the tests we conducted to check our localization system, which is what we call, finding our position in the world. Okay, I think slide just changed. But yeah, it was the localization system. So we have to use all these different sensors, and thankfully, because we're such a good institute, we actually have the funds and the support to access them. We constantly have to make deals with companies, ask institute for money, and we're able to use them to build our product. So next, if you go to the next slide, we're going to look at the different sub modules that we discussed earlier. The first sub module is computer vision and machine learning, which Dhanush is going to talk about. Dhanush?
Yeah, so hi guys, I am Dhanush, one of the members of the software module. So Suraj was just talking about how we get data from various sources and various sensors. And the next obvious question is what we do with this so much amounts of data. And again, one important thing is among all the sensors that he mentioned, the most important sensor and the most reliable source of information is of course the stereo camera. And this is where the heart and soul of software comes into play. So whenever I talk about software and whenever I say the two words, say autonomous systems, and when I say software, the first thing that pops into your mind is vision or computer vision, and this forms the entire crux of software. Basically what we do in computer vision is solve two fundamental and critical problems which are essential for any self-driving vehicle. The first one being lane detection and the second one being obstacle detection. And here in this slide you can see the model that we have developed for obstacle detection in play. So yeah, the previous slide, the left one was a tire detection model, and the right one that was a sample video of the exact IGBC course that we will be participating in. As you can see, the very good accuracy in detection of the pedestrians, the barrels, as well as the stop signs as well. And we have been using machine learning models to train for finding these obstacles. And of course, the most important thing in fact, an age-old problem we could call it, that's the problem of lane detection. Here you can see those videos are actually test videos that we have taken inside IIT campus, and we are actively testing our lane detection algorithms on them. And what we essentially do finally is to fit polynomial into the lanes, and this is where we continue from where we left off here. This is what we call as planning, and we feed the obstacles and the fitted lines into the control module. Path planning module.
Hello, hi, I'm Dhruv Maru. I'm a second year BTech computer science student. I'm also a member of Abhiyaan software module. I'll be walking you through our planning and control modules. So let's say you got all the data you wanted. You got where's everything, right? Where's the obstacle, where's the barrel, where's everything you got that, where the lane is. Now how will you get the path, right? How will you figure out how do I go from here to here without crashing into anything or without going out of the lanes? How do I go from here to here smoothly, in a smooth path, in a reasonable path? So that's where the planning module comes in. So this is a video of parallel parking. So let's say the vehicle is there. This is simulation by the way, right? You can see there's a vehicle there and it has to park between those blocks. So it will first figure out a path and then it will use that path and use the controller to actuate and follow the path. So path planning, as I described, basically the problem from going from point A to point B. In this problem you have to consider multiple factors, basically the obstacles, the barrels, the constraints, let's say you cannot cross the lanes, or whatever constraints we have, the physical constraints in the sense of the vehicle body, right? Need to make sure that none of the vehicle components hit any of the obstacles. So this is the parking maneuver that I worked on. Now comes controllers. So let's say you got a path. Let's say you figured out a path which is smooth enough, which is reasonable enough, and it doesn't hit anywhere, it doesn't crash, it's good enough. How will you make sure that the vehicle follows the path? You can't just, it's not as simple as just giving some keystrokes and it will follow the path like a video game or something. No, you'll have to make sure it follows the path. So for that you'll have to set up a feedback loop of some sorts. You'll check at every moment whether it's following the path or not. You'll check at every instant whether it is off track or not. It's like rerouting. Let's say it goes a little bit off track, you will again ask it to go follow the path. So it's a continuous process. It's not a single shot process that you can say that follow this path and it will just follow the path. That's not how the real world works, right? There's some inaccuracies, there might be some errors. So you need to check at every instance and make sure it's following the path. And the essential thing in all of this is that this has to be really quick. This has to be really fast because the whole navigation depends on this. If this lags, the whole navigation stack falls down. Reason being, of course, if you're lagging behind in the planning, there might be an obstacle here, you didn't anticipate it, you just crashed into it because you didn't, your plan is not in sync with your controller or something. So this has to be really fast. The whole pace of your control loop decides the pace, like how responsive your vehicle is. So there are multiple controllers, let's say Pure Pursuit, Stanley, PID. So this is a non-linear NPC controller which the team has written and which is being showcased in a nice geometric path. Next slide. Yeah, so basically all of these things as I showed were in the simulation, right? So, and almost in every case we first run this stuff in simulation before running it on the real vehicle. The obvious reason is we don't want to break or crash the vehicle into something, right? So most likely we are not right at the first time, which is why we tested first in simulation. And once we are confident enough that it's good enough and it won't crash into anything, we'll test it on the real vehicle. And secondly, testing on simulations also helps you create your own scenarios. You don't have to go there and move blocks manually. You can just drag and drop. So yeah, this is a simulation video of Bolt, where the blue lines are basically LiDAR rays, those sensor rays. Could you play the video? Yeah, so this is a simulation video of Bolt. So the simulator which we are using is called Gazebo. You might have heard of it. It's a really good simulator for 3D simulations. Next slide. Yeah, so all of the things which you use, you can see a bunch of a set of things which you use. We use ROS, which Amos talked about. The Gazebo, which is the simulator. Python, C++ are the main programming languages which we work in. PyTorch, again we use it for training models and all. Arduino for systems level stuff. OpenCV for computer vision. We use version control systems like Git. We mainly work on Linux all the time because ROS is most compatible with Linux. Yeah, that's all. So if you join the software module, you get to learn all of this stuff, right? So you get proficient in all of this stuff, and trust me, this will help you much more than anything else. Okay. So you'll be writing stuff which is practical. You'll be writing stuff which will have impact. Your code will be running in some real software, like some real vehicle, right? It will have some real impact. It won't be some code that you wrote and submitted on some random website for some random points. Okay, it will be much more significant than that. So you have to get hands-on and practical experience. That's all. So that's why I suggest you guys to join the software module because it will be a really helpful experience and you'll be working on real stuff. Now, how do you join the software module? Well, you'll have to finish the application, which the timeline will be shared with you. The application, the only thing which you expect is that you need to apply some effort, right? We need to see that you put in effort in the application. We don't want some random submissions. We want to test your problem solving skills, because the programming which we are doing here is not just writing code like a machine. It's also thinking. You have to think through the problem. You have to figure out what's the best solution, what's the most reasonable solution. And you have to research stuff, of course. We don't expect you to know everything from the start. You have to research stuff, Google it, read some books, read some blogs, watch some tutorials, right? Whatever, right? So that's what we expect from you in the application. We are looking forward to the application from all of you. Next slide. Yeah, so in case you have any questions, please ask them. This is a small collage of all the things that we've been doing. So this is again simulation video of some map. This is the lane detection video of lanes of road. This is Virat, by the way, and this is the video from my time. So basically, what we did was we made Virat dance on it, real beats. Yeah, so you can have fun stuff like this also, right? This is the ideation stage where we are figuring out how to detect lane boundaries, lane lines. So this is basically a snapshot, a very tiny snapshot of all the work that we will be doing. Right? It ranges from computer vision to planning to ideation to having fun like making robots dance in simulation. Right?
Okay. Thanks, Dhruv. So yeah, that's it for software. One thing I want to mention right now is that your branch is not the most important thing in this room. Okay? Even software module has, I think, people from all different branches. We have only one CS there. Right? So don't be afraid to try something new. Put your genuine effort in the app. Next up is what is actually one of the most important modules, is design. So here's Sriram is here for design.
Hi guys, how are you all? My name is Sriram. I'm a third year undergrad in Naval Architecture Department, and I'm leading design working for Team Abhiyaan. Okay, so what does Team Abhiyaan design do? Basically, almost half the things what the other team members told might have been straight above your head. So we explain all these technical complexities to a non-tech guy in layman's term. So for that we have to closely work with each module member and work according to their emphasis and preferences. And by the way, design module is equally challenging and important just like any other technical one. Why we exist. So we basically design handles all the poster works, videos, teasers, t-shirts, logos, and we use softwares like Photoshop, Illustrator, Premiere Pro, Canva. And don't be scared when you see these names of softwares. If you have the creativity and just the enthusiasm, you can just walk into the team. You learn all this during your tenure. Why join design? Okay, so you can explore your interest in designing, which is basically everything. Then you can use your so-called unused imagination and execute your out-of-the-box ideas. And the learning skill in design is pretty huge, because unlike other teams in which which does design, our design works won't just stick around institute. Like we make content for sponsors, other competent teams, which will be competing against in international spheres. So the added advantages, the fruitful learning curve, and we learn a hell lot of things in apply. And just like every other team. Okay, so these are a few of the design works which were done during the last year, the t-shirts and posters. And just like any other team in NCSS, all we require from you is input.
Hello everyone, I am Mehboob Ali, a third year undergraduate in the Department of Chemical Engineering, and I am here to introduce the final module for the day. Is it already tiring? Okay, I will make it short. A quick exercise. You have seen 4 modules already. What would be the 5th one? Any guesses? What's missing? Oh, spot on. So we have the business module. money is all you need, they say. That might not be true. Money might not be everything, but it is something very important for a team like Abhiyaan to sustain itself. We have different teams. We can have mechanical team to build the car together. We can have electronics team to wire it. We can have software team to program it. But to take everything together, ship it, participate with it, for that we need real money, we need funding. And as you guys would be thinking, we do get funded, we do get supported from the institute themselves. We do get significant funding from them. But for our big dreams, that's like very near amount. For example, you guys would have seen the bolt yesterday, right? How many of you have seen it yesterday? Okay, so I have maybe the last question for the day, for the goodies. Can you estimate what would be the final cost of that car? Raise your hands, raise your hands. I will take 4 answers, and whoever is close, I will be giving this. Yeah. Please use the mic. 28 lakhs, next.
3 lakhs.
3 lakhs, what is it? Okay.
25 lakhs.
25 lakhs, 1 lakh. Can you 20? 50. What's your total?
The final product will be around 6.5.
Okay, I think that's spot on. Like, it's not the exact amount, but the amount comes out around 15 lakhs. Sorry, oh, very handsome. Sorry, I don't have. Okay, so yeah, we had guesses from around the spectrum, but like 15 lakhs itself is a hell lot of money for a student team without proper funding, only institute funding. So we have to bank on industrial collaborations. For that, what the business team do in a nutshell is, we try to build a brand for ourselves. We try to explain to others what we do, and 2, we leverage it to approach partners and get sponsorships. That is what we do. So on the right side you can see the PR. The PR side is where we explain it. So for a group of people, we have a convenient space in C5 for our experimentations and building. So if they do and keep it to themselves, it's not going to serve the purpose. We have to explain it to the outside audience for 2 reasons. One, for it to have impact on the society, for it to inspire others. And secondly, to show others what we are doing and get their support, get their help. We can't work in isolation. We can't work in isolation and achieve these much great things. So that's what PR team do. And on the left side, you can see the CR side, the corporate relation side, where we look for sponsorship. Just building a brand and putting it there is not enough. People won't come. You have to approach, you have to have targeted approach to the companies who will be willing to sponsor us. For that, we have the sponsorship side of things. So now, what all we do under this team can be classified into 4 brackets, broadly into 4 brackets. On the left side, you can see the sponsorship side. First, most important part is prospecting. So you have a lot of companies in the industry. Now you have to be intelligent, you have to be smart to select and approach the right companies who are worthy to sponsor, who can afford to sponsor, and also are willing to sponsor. And sponsorships can be of 2 types. We usually have sponsorships of 2 types. Either they can be monetary, where they will be giving us funding directly and we do branding in return. Or it can be kind deals also. For example, for our golf cart, we will need a lot of components, from LiDAR to radar to sensor, etc., etc. And we will approach companies who produce them, and they can sponsor those products to us directly. So we have those 2 types of sponsors, and for them we need a proper pipeline for prospecting companies. And then the next step is, once they are on board, we have to negotiate with them and close the best deal that's in the best interest of our team. And on the right side, you can see the PR side of things. First, the social media. That's like the most important PR in today's age. That's important for us to publicize what we do. And secondly, for the branding also. As I mentioned, for the companies, we will have deliverables. We will have to brand them. So we need regular engagement in our social media handles. And we work closely with the design team. We give inputs. The design team work on the inputs and come up with posters for the social media. And on the public relations side, beyond social media, we do get featured in articles, we do featured in different media houses, newspapers, television channels, and even web magazines. These are some of the sponsors that we have. For example, you can see Roots, the second one. That's the company who sponsors the full electric vehicle. We procure the vehicle from them, the electric vehicle, and then we convert it into an autonomous vehicle. So they gave it as a sponsorship, under a sponsorship deal to us. Similarly, we have all these sponsors. Moving on, these are like news articles, news reports where we were featured. We were featured in national media as well as local media like Times of India, NDTV, News 18, Financial Express, etc. Now finally, to give, this is just a graphic to put into perspective a realistic picture of what you are up for if you are selected for the dream. The size of those circles are proportional to the amount of effort that you will have to put. So you might be surprised to see a small circle for closing deal, even though that's the most important and the thing that gives you the most satisfaction. It just says that that's the fruit that you get when you hunt for that much, when you put that much effort in hunting. So it's a good experience. Like it's not easy, but like once you get in the team, we'll be training you to target companies, approach them, negotiate with them, and develop your soft skills in the go, and finally become good communicators and good negotiators. Finally, perks of being in the team. This is not only for the business module in general, for Abhiyaan in general. Solve real life problems. We started with a slide of what the problem we are set out to solve that has impact in society. Secondly, work with our big industry partners. That list was short. We have other industry partners also. So you get to work with them directly. You get to get their expertise in the field. You get to get their expert opinions. Internships. Yeah, many of our teammates, many of our previous team members have landed internships through these companies that we have as our partners. Finally, international recognition. Like, what better opportunity to represent IIT Madras and beyond that, represent our country itself on a global arena and win accolades, win recognition for your country, for your institute, and for yourselves. That adds a lot of value to your career as well. And finally, contacts. That's like for a competitive team that's working together for so long, engaging with a different set of people, the contacts you get, that's like really valuable. That's all from business module. I will hand over to Shashank for explaining the recruitment procedure.
So yeah, for what we have all been waiting for, how will the recruitment procedure be? Yesterday also we got a lot of questions for the recruitment process. So yeah, I'll walk you through the recruitment process. So first, today after the session, by the end of the day, we will release the applications for all the 5 modules, and the recording also will be shared. Next, the application submission deadline will be 18th April, 11:59 p.m. And before that, throughout 12th to 18th April, the 1 week you have, we'll be having a module-specific fun day session. And if some of you are not available or going home or something, we'll have it online as well. So there'll be a module, any questions or doubts you have in your apps, you can get it clarified. We'll share the relevant contacts also by today. And next, 21st to 24th April, once the app submission is done, we'll evaluate your apps. And if you're shortlisted, we'll have interviews from 21st to 24th April. And these will be offline interviews. And then, yeah,
Then 26th April will declare the results and then will officially be part of Abhiyaan family. Yeah, that's it with the process. And this is our team, Team Abhiyaan. Thank you guys, and we are open to any questions or doubts you guys have. You can shoot your questions now.
Yeah. If you have any question for any module, right, then please either come up here, raise your hand. Anything's okay.
We are officially done with the session. If you have any questions, you can ask.
Okay,
Just a
like
second.
how
I'll
many
get back to you.
students will you recruit?
Guys, wait a minute for the questions. Some of them are leaving. We'll then take the questions.
We'll answer that shortly. Just a second.
And also one thing guys, some of the questions may be important for others as well. So yeah, just letting you know.
Just an information for the people who are leaving, you might find something useful in the answers that we give to the questions that your friends raised here. Just give us a second, we will get back to you. Okay, yeah, we'll start. Yes, the first question, can you please start again?
So basically we don't have a specific number we have in mind. If we are mainly looking for quality people, the more the number of quality applicants we get, we'll recruit that many. There is no specific number as such.
Yeah, here. Yeah, next. Yeah, we'll get back to you.
So I had two questions. One, what would be the time, how much time would be required to allocate to this team if you were to take up this? And secondly, in our application, are we required to select one module or can we apply for multiple?
First, I'll answer the second question. Yeah, you can apply for multiple modules. You are free to apply. And regarding the first question, the time commitment. So mostly, whatever work we have, we expect you to be creative and innovative and complete the work. If you are able to complete it fast, then you do it fast. But if you want a number, on general sense, at least 7 hours a week would be required for the team. But some, obviously, there are exam time or this holidays, that and all, obviously everyone will be free. But generally, we would have around 6 to 7 hours a week, and it's a serious commitment to the team.
Yeah, there's somebody from there. Anyone else?
Like for mouse robber, you are making a test bed, right? For replicating the Martian surface. Like, how are you planning to simulate the Mars gravity?
We have drop test wherein we have simulate G by 3. It is possible and we have done it successfully in IIT. We have a yes, that's exactly what we do.
Anyone?
Prerequisites for software team?
Yeah.
Prerequisites for software team. Okay. So if you guys at least should just take a look at the app. So very basic programming knowledge is expected. Like simple stuff, whatever you learn, CS 1100. You guys have that course, right?
We will have.
Okay. That was the first year course. But some basic programming knowledge you need to have. But other than that, most of our work is you have to research and problem solve. So even in the app, attempt as much as you can. A lot of these things you'll pick up as you go. So the basic knowledge is enough, but you should be ready to learn and learn fast. Okay?
And what are the future goals for electric vehicles, like here in Abhiyaan?
Okay, so I think we had a timeline slide, but I'll just recap it here. The next most prominent goal is that we want to conduct an autonomous run from main gate to Himalaya by the end of next semester. That is the next main goal for the EV, for the Bolt project. It's very software heavy, and like in Mac also have to increase the reliability. Okay.
Anyone?
Okay, here in front.
So, you showed your timeline that in August 2023 you are expecting collaboration with ISRO. So, what after that?
So basically, everything that we do can be optimized. So we'll be optimizing. See, doing it at a real scale in a simulated environment is something different, and doing it in an actual environment is something different. So we'll collaborate with ISRO, get all the data that we require. Now we have only sample data that we require. When you collaborate with ISRO, you go by the proper steps that's involved. You have to consider a lot of parameters. You have to fix the dimensions that the payload can take. You have a variety of concerns to do. So basically the rover that we make cannot directly be put in a rocket and sent it. So we have to basically modify or even build a new rover such that it is compatible with ISRO or whatever guidance they have. So that is what we'll be doing after the collab. Any more questions from me? I see a lot of hands there. Okay.
Anyone?
You can please raise your hand so that we will give you the mic. Ask it on the mic.
Okay.
Okay, I just wanted to add something.
Okay, yeah. We have one question there.
Who?
Last row, and there's one more question. There.
For the next IGVC, will Virat itself participate, or what is the plan for that?
So IGVC has two parts, right? Spec 1 and Spec 2. We're calling it Virat and Bolt. So as of last year, the previous competition that we attempted, we got second place for Virat. This year we are going again in June, and we're planning to top off that Virat competition, come first place and leave it. And in the future we'll only participate for Bolt.
Will we also be going for the competition if we get in Abhiyaan?
I am not promising anything right now, but you have to work for 1 year.
Okay.
It's not something that it's there.
Anyone?
Somebody in the front, right?
So if we are recruited, will we be working with both rover and the autonomous car?
Yeah, when you are recruited to the team, you are recruited to Team Abhiyaan. You are not recruited to any of the specific projects. Once you are recruited, depending on the interest you have, once we brief you through the work, exact work you will be doing, depending on your interest, you will be working on one of the projects. But if you have the bandwidth and the time to work on both the projects, you are welcome to do that as well. Yeah, it is depending on your interest. But recruitment is done for Team Abhiyaan, not for any of the projects in the team.
People did you recruit last year?
Good question.
How many people did you recruit last year?
If you want, approximately I think 5 or 6 per module, right?
Yeah, I think 5 or 6 per module.
Yeah. Actually more than 5 or 6, but honestly it depends a lot on the number and quality of people we get. So only after we actually get your apps, we will decide how many we are going to take this year.
Don't worry, this year we are planning to expand the team because we have taken 2 big projects. So number is not obviously constraint that we have.
Yeah, last year I guess it was completely online for us, so the number of recruitment people are actually less. So this year we expect more and we want more.
Also, don't feel the application is just some sort of a challenge or something. It will be a really good learning journey for you as well. Like it will get you kick-started into all of this stuff. So by the time you finish the application, you yourself would have learned a lot of things. So there's nothing wrong with applying, right? You're not losing anything at all.
Do you guys have any questions?
It's a general question. Why name Vira? Is there any specific about it? Is it Vira for Virat Kohli? I guess no.
No, it is not because of Virat Kohli. We were just we asked the audience in our audience on our social media handles what we had a set of options and we asked and the most voted was Virat. We had a set of options. The most voted was Virat and our team was also happy with that name. And Virat is a catching name. It's easy. People will remember. So we kept it as Virat.
Okay.
If and when we are, if we join the team, like how involved will our assignments will it be as how do I frame this? No, how involved will we be with the actual project? Like I don't want to accidentally like connect red wire with green wire and make it go backwards.
Oh, so we have done that actually. We have broke stuff. We have already, as in like we have broke stuff before. We have repaired stuff after that. So the thing is that there will be people who will guide you at least through the initial processes. After you get comfortable with the team, comfortable with what you are doing, once sufficiently good theory knowledge is available, you will be you'll be confident enough to directly work on it. You don't have to worry about stuff. But the thing is that while you guys are working in C5, you should be careful and safe. It can be a dangerous place from experience.
Who lost their finger? Somebody. Okay.
So, as always, like with great power comes great responsibility.
So you need more responsibility because if you become more senior members, chances are that you'll have more costly equipments under you. You should be more careful. That's it.
Okay, one more question here.
Generally, what kind of qualities are you looking for?
See, it's a very general question that to answer, but most important thing is that you should be self-driven and take responsibility for the work you're doing. Yeah, if you get some task, you're expected to do whatever it takes. I'll just give a software example, but not everything is available, even from online sources. Sometimes you have to go contact people, contact pros, contact companies, to get things done. So getting it done however you can. Anything, Amos?
I would just add, like, you have to be passionate about what you are doing. You will have enthu initially, but that could die out. But if you are passionate, it will never. So once you guys join the team, try to make sure that you are passionate enough about what you are doing over there.
It is a serious thing, right? Competition teams in general and Abhiyaan also. We expect that you guys work up to the standard, right? Last row. Why are we running so much? Who raised their hand? Think he's scared now? Think AMS lost your finger standing here.
No. I by mistake stuck my finger inside a fan, running fan. Although I was warned the day before.
In general, I think we'll be releasing, there are phone numbers in the email. and they'll be on the app too. I think the app will be released tonight. Sam? Yeah, tonight. Take a look. There will be numbers if you want to contact people, fund days, general, anything. We're always available.
We prefer it to be offline. I mean, you guys are here, right? If you guys come and visit us, we would also feel happy.
Depends on your enthu. The more enthu we see from you guys, the more effort we'll put. So, yeah.
Any more questions?
Regarding the recruitment, like the terminology app applications were repeated, no? So for freshie, I just want to make sure you guys are aware of what that is. What is an app? Yeah, so it's just a questionnaire with a set of task questions that you have to work on for a week or two. I'm sorry, that's all.
Is there any questions? If possible, I thought I could add a story that what I had in Abhiyaan. So this happened like during my internship season. So I couldn't get any internship from anywhere for a while. So the thing is that one of the companies, Lam Research, that actually I got into, they asked all of the questions in the interview that based on my Abhiyaan experience as electronics module member and team head, electronics module head. I was asked about what we were doing in detail from one end to the from the lowest end to the highest end. We were asked about everything what was happening in it. So to be honest, Abhiyaan actually helped me in getting an internship in lab research, and it's a very good place to work actually.
Any more questions?
Is this stretching? A lot of people are stretching. It's been long.
I also wanted to add this as well. So what happens is that generally, whatever you guys study in courses, in IIT Madras courses, you will be learning it in theory generally. The thing is that in Abhiyaan, there is a chance that you will actually implement it. So I joined Abhiyaan in my first year. Hello? Yeah. I joined Abhiyaan in my first year, and I actually learned concepts while doing it in practice compared to after which I learned it in theory. For example, I was working on some stuff like buck converters, MOSFETs, all of those things when I was in my first year. In practice, I was designing circuits for that. But after I got into the team, after second year, during my second year, fourth semester, one of the courses were entirely based on that. So the thing is that you may not learn exactly what is happening in theory, you may not exactly use it in practice. But the thing is that there's a very good overlap between them, and it will give you a great intuition of what things will happen in practice. So if you guys want to implement something in real life, whatever you guys understand in theory, to get much more intuition, you can definitely apply for Abhiyaan.
Also, Abhiyaan gives you a great opportunity to learn new ways. Most of you might have got the branch that you wish for, like you guys didn't get this branch, you guys didn't get that branch. It's not your interest, like the branch which you had. I think it's most of you guys is the same way. So Abhiyaan gives you a way to pursue your dreams, whether your interest lies in management or software or elect or mechanical. So like the software heads, the two software heads we have are like naval as well as mechanical. So your branch doesn't matter which module that you will work on, it's your interest. So if you're interested in what are modules, your branch doesn't matter. So that's another thing.
Software is actually an EP majority module. EP. Yeah. 33%.
Okay. So in general, the module that you apply for is just an entry to the team. You are free to explore other modules if you interest you. It's not that we restrict you to one particular module. Say you apply for mechanical, it's not that you just only work for mechanical. You are free to explore other modules as well. I personally joined as a mechanical module, but I do both electrical and mechanical stuff in the same day. So you are free to explore whatever interests you. Also, I am from ED. From ED, ED Mech, I see. Mech, somebody. Okay, I see only one mech there.
Only one mech?
2, 3, 4. Yeah. Yeah.
How many elect remaining? Elect. Okay, that's good.
Electrical people here. See few there. Yeah. Navak, maybe. Oh, Navak is the majority here.
Huge.
Okay, huge. Meta, Meta. Yes. CS, I see one hand going up the whole crowd. Okay. BT, BS. Oh, people are not there. Arrow. Oh, civil. Oh, yeah. Okay, you're civil. Civil better. Yeah. Humanities. Anyone from ET? Okay, one right.
Yeah, one course was never mentioned. MBA.
Ken.
Oh!
So any more questions?
Any more questions? We'll be leaving the auditorium soon. So if you guys are not interested in directly asking to us, you can contact us outside or you can contact us through WhatsApp as well.
For specific module queries on the apps, we'll have the module head's number and teammate's number. So if you have any specific queries regarding to one particular question or how to attempt that particular task or something, you can always reach out to the numbers mentioned there or the email is mentioned there.
Yeah, we'll be staying back here for the next 10 minutes. We'll be here. You can come and directly ask us questions.
You can directly ask us personal questions as well.
Hope you all enjoyed the session. Thank you guys for joining.
Thank you guys for joining. Have a wonderful